Hello friends, in today's video we are going to talk about important DAX filter functions or most used function to solve the business use cases. Those are calculate table, filters, filter, keep filter, all except, all selected. These 8 functions are very complex and powerful to manipulate the data context and create a dynamic calculation, so which will help you to solve the business use cases more effectively, more easily. Let's get into detail of each function. We'll start with calculate function first. Calculate function evaluates an expression in modified filter context. Most of the time we use the calculate function along with our aggregated functions to filter out the data and aggregate it out data. Basically it takes two parameters. One is like a filter context, other one is kind of per measure that will take. We can apply also on the using the boolean or table or filter functions within the calculate function, where you can filter out the data further easily. I mean, without using the filter functions, you can filter the data simply. But let's get into the some examples. So in the first query, what I'm trying to do here, I'm trying to fetch my sales amount where, where my order date is equals to max of my order date. That is nothing but first it will take the max order date from internet sales, and then it will take the whatever the sales amount for that order date, it will sum it up and it will get displayed for us. So the first query if I execute, that's how it will work. You can see here. So 2643 is our um, sum of the internet sales amount for the where max order date. And that same way, here I defined the measure wise. First I created the measure and then I call that measure in my evaluate function. Evaluate function statement is nothing but like a select statement in DAX. And now similarly, you can do same thing even by declaring the variable and call that in your evaluate statement. So here also I use the calculate, and the first one is I take it as my measure, and the second parameter I take it like filter. So here I'm trying to filter out my data and then take the sum of that particular sales amount value. Now if I execute the second statement, I get the my sales amount where my order date is max of order date. Similarly, you can have multiple filter conditions within you know this calculate uh, function. So here what I did, I just added the filter. Within the filter I used the two condition. One is the order date, other one is the currency code is 100 again. If I execute this, then I'll get the same results. Not only that, I mean, without using the filter condition, we can also filter the data. So using the one filter to filter out the data is not only choice. You can remove the filter. Okay, in this scenario what I'll do, I'll simply remove the filter and then try to fetch the sum of sales amount for where my currency code equals to 100. Let's see what will happen. So here now if I execute this, again the data will be sliced where currency code is 100, and then it will fetch the data of the sales amount. See, I didn't use any filter function here. Without using the filter function, the calculate accept the expression and slice the data where the currency code is 100 and aggregate that sales amount for that currency code and get displayed. And similarly, we can also write um, you know some additional if conditions that we can apply. So in my this query, what I'm trying to do here, I'm trying to calculate the sales flag. If my sum of the sales amount value is actually less than 2500 based on the customer id wise, all the customer IDs I'll take it based on the customer IDs. If my sum of the internet sales amount is less than 2500, then I mark that particular row as a low sales. Otherwise, I'll mark it as a high sales. If I execute this, I'll get the detailed level of information because even though aggregated here, it will be calculated at each row in the internet sales. That's how it will work. And moving on, even we can use this calculate function in the summarize function along with summarize function, where I'm trying to uh, do my flagging wherever I have the so the sales amount is uh, 3 million, less than 3 million, I mark it like a low sales. Where if my sales is greater than 3000, I consider that as a high sales. You can see here along with geography wise, first I fetch the sales amount. For that sales amount, I created a new sales flag based on the threshold value. Anything is below 3 million, then we consider that as a low sales. Above that, we consider that as a high sales. This is how you can use the calculate function. It's a pretty straightforward and simple, just to, and it's very powerful to slice the data based on your expression. And then that's how the calculate function works. And moving on, we're going to discuss on the next function called calculate table. Calculate table is another important function in the DAX world, where it will take the filter context, whatever the filter that we apply in terms of the expression, and the written value will be always table expression. Basically, it will return the virtual table, whatever we write the function based on that filter condition, it will return the virtual table. And this table will be there in the your virtual memory, which is the RAM, and it will be reused, not reused, it will be used along with any evaluate statement. Okay, let's get, I mean, it works like the same way or like a calculate function that we discussed previously, but the difference is calculate function will fetch only the scalar value, whereas calculate table will return the table values. That is the main difference. And this calculate table is very handy, to slice the data and fetch the data in the table format based on the given filter criteria. Let's get into some examples. Evaluate the first query. You can see here I'm trying to create a calculate table for my sales amount and tax amount simply by using this method. And then here you can see the information got calculated. Similarly, the next statement what I did, this time I want to bring my sum of sales amount and the tax amount only where my currency code is 100. So this is how we write the filter to slice the data in the calculate table. Not only this, you can also use the filter function to slice the data and create a calculate table. But in our scenario, I used only the currency code to slice the data. And if I execute this statement, it will fetch the wherever the currency code is 100, and it will aggregate that sales amount and tax amount and bring the data. Uh, so now here, this one is actually again along with the currency code 100, and I'm trying to fetch only the customer ID 11704. Only that customer ID I'm trying to fetch it. What I'm trying to show here, we can use the additional filters with comma separated while we're doing the calculate table. If you notice here, the first statement we used only one filter to slice the data, but here we use the two filters to slice the data by the comma separated. Now the next one is the you can write simply this is the no just I'm trying to bring all my product dimension table columns data where my product class is M. Okay, and then you can also have the multiple filters in case if you want to go with one more filter. So we can write like a color equals to red, then you can do that, it will work. Now it will bring the all product columns data where the class equals to M and the product color is red. That's how this virtual table get created. Not only that, you can also create the nested calculate tables in the DAX world. So here what I'm doing here, first I filter out my data where class equals to M, and again I use the calculate table where my product reorder point is 600, and then I trying to fetch the data. Now you can see it's a filter the data double. That means the nested calculated table is possible. Let's say there is a scenario where you might take calculate the table first on top of this calculate table, then again you will use further some expressions. To do that, you can easily do using the nested calculated table. So both calculate and calculate table are identical, but the written type is different. So that's how the calculate table is works. And then the next function that we are going to talk about is filters. Filters function is actually it's a very handy function. Basically, we don't use this filters function to filter out any data. Instead, we can see what are the filters being selected in our DAX expression. Let's say if I execute the first statement, what will happen, the behavior of the filters function. Here what I did the filter at product color black, right? Now what are the subcategory names are belongs to this black color, that information will get displayed here. Basically, based on the filter function that we applied, what are the equivalent values that we select in our expression, then it will fetch those list of the values. Let's say here instead of the subcategory, if I change this query to only keep the product color, then this time it will bring only the black color, because that's the filter we applied in our query, right? So now if you can see here, and then now the black color is displaying. So just basically the filters function will help you to know which are the filter being applied in our expression. Okay, the DAX expression. Now let's get into more examples. Now you can see here again I applied the color, applied the filter on the product color equals to black. But after I apply this filter, now let's see how many equivalent subcategories, what are the subcategory level count of rows that I fetch it. You can see here. Now let's say filters function here, product category name, based on the black color it will fetch the product category names. On top of it, it will count the rows, how many records are there in the product dimension for the black color, and the same count will get display here. And if at all you want to see what is the individual count that you are looking for each product subcategory based on your filter that you applied, you can execute this statement, and it will show each subcategory wise how many rows are there when your color product color is black. So that's how the function works. Basically, the filters function, I mean, you can achieve this statement, whatever the data that you see here, right? You can achieve this count of rows based on the subcategory different way. But the main functionality of the filters is you come to know what are the filter being applied in your expression, and let's say you want to aggregate anything based on your column and see what is the impact for each dimension attribute member. So that's how you can use the filters. Net filters function is just only help you to know what are the filter that you applied in the expression. That's about filters. Now next topic we are going to talk about filter function. Filter function is basically help you to filter the data, which is nothing but you can slice the data based on your condition and fetch the records from the different dimension and fact tables. That's how the filter works, and you can see a couple of examples. I captured simple examples, and then here what I'm trying to do. So I want to create a calculate table, the virtual table, where my uh, product color is black. So I want to display the all columns from the product dimension, and I want to take only the rows where my color equals to black. Now if I execute this query, you'll get only the black records from the product dimension, and then it will be stored as a calculated table. So here we use the only one condition, and same way you can use many values that you can pass using the filter condition by using the in operator. So when you use the in operator, you need to use the flower brackets to pass the values, multiple values. And then if I execute this statement, so now this time it will bring the data for both black and red product colors, and it will fetch all my product dimension values. Not only that, so the filter function, you can use multiple filters at different attribute level. In this query, third query, here I'm trying to fetch the black and red color products where reorder point equals to 3. And again, this is how I use it. So first I use the filter expression, and first we need to mention the table name, and then the first filter condition, and then I use the operator. So end operator, that is the end operator, or you can use the or operator also by using the double bars. Okay, but it will take the filter function two values. First one is the dimension table name. Okay, what are the initial table dimension or fact table that you're referring, and then your filter conditions, it will take it. That's how the filter function works. It's a very simple and straightforward function, but it's a very powerful function to slice the data based on our business requirement. Now we'll move on to the next function is keep filters, keep filter function. Keep filter function is another important function which modifies the filter context behavior in the calculate and calculate table function. Basically, whatever the filter expression that we used in calculate function, calculate table, using the keep filters, it will override the behavior of both the calculate and calculate table function. So let's get into one example and try to understand how the keep filter function will works. Basically, keep filters is actually intersects the values of multiple queries. Let's go to the one example here. So in this query, what I'm trying to do, I'm trying to fetch the data of my sum of sales amount for different filter criteria. First, if you notice this, first three rows are actually, it's a plain where I'm trying to fetch one time bikes sales amount, other time is clothing information, clothing sales, and then bikes and clothing sales amount. Even the fourth one also, I'm just trying to use the or clause to fetch the data. Uh, that's where you get the uh, both clothing and bikes, and even there is no difference using uh, the fifth one. The fourth row and fifth row is giving the same result by using the keep filters. There is no difference. And then next, go to the sixth row, which is the one keep clothing or bike sales. Now if you notice this, I'm using the nested queries. First I fetch the clothing information and the bikes information. On top of it, I just use the clothing information, but still it fetches the both clothing and bikes information. Even though the outer query I asked what happens, still it bought the both bikes and clothing information. When you use the nested queries, what will happen? The lowest filter that we applied in the calculate function, that will be taken to the precedence. Since even though we use the outside query where we filter the clothing, still it's ignore that filter, and it take the precedence of the inside calculate function, whatever we wrote the expression. That's a behavior of the calculate function. Okay, the lowest expression that we wrote, that filters it will take into the account. That's how the calculate function works. uh, Now coming to these two keep clothing or bikes. Now you see here I mentioned keep filters. Okay, where I'm trying to say bring the sales amount for clothing or bikes. On top of it, I just use the again one more time I use the clothing, trying to fetch the clothing sales amount. But this time it fetched only the clothing sales amount, because the keep filter is actually intersects the two filter conditions. Since we use the two nested calculate function, right? So it combines the filters from both inner query and outer query and intersects the common values. In the both queries, the common filter is clothing. That's the reason it apply the common filter to the data and fetched only the clothing sales information. Even if you take it again the last query, so that's where you can see here. First we're trying to fetch the clothing and bikes information, then we're trying to intersect again we're trying to fetch the clothing and then bikes. So now what happens in this query, the first two queries, what happened, the in clothing is actually common filter between the two queries, inner query and outer query. Now it fetched the data for clothing information, clothing sales. But when it comes to the third query, the outer query, wherein we are trying to fetch the bikes information, which does not exist. As I mentioned, right, always uh, calculate, if you use the multiple nested queries, it will take the precedence of the inner query, whatever the lowest inner query that we used, it will take the precedence. Again, the keep filters, if you use it, the keep filter will do the union between the all queries, and based on the common records, common filters that we apply, it will bring the data for those common records. That's how the keep filters function work. Moving on, next one, we're going to talk about the all function. All function is actually one of the useful function which will omit your all filters that we applied in the DAX expression. Irrespective of the filters, whatever the function, whatever the aggregation or anything that we do, the all function will omit all the filters in the DAX query. Now let's get into the examples. Here, if you've noticed, if I execute the first two statement, evaluate customer and evaluate all customer, there is no difference. You'll get the same rows, because we don't have any filter criteria. But when it comes to these two queries, the other two queries that I'm executing, so first query is actually fetching the all customer IDs. Second query is fetching the customer IDs, count of customer IDs, where gender equals to M. Now, if I execute this query, what will happen? You'll get these values, because first in the variable I'm capturing the count of my customer IDs, and then I'm using that variable in my inner query. But this time I'm using my gender equals to male. So now what will happen? Since it's a variable, the count of records already calculated. That's the reason you see 18484, because the gender filter is not applied, because the variable is outside of this evaluate function. And the count of customer IDs, this is where the gender filter is applied. But the same query you can write in different way by using the all. So if you can write using the variable, but the problem is when you have too many variables, then it will be a problem to maintain, as for the standard, maintaining the standard wise. Using the variable instead of the variable, we can write the same statement in different way by using the all function. So now if you look at here, the second query, we wrote the same statement without variable. We just use the all function. Inside the this statement, we just use the context and all customer IDs. We're just telling that take the count of all customer IDs by using the all function. So this time all function will actually not take into account of this customer ID gender filter, customer gender filter. It's irrespective of this gender filter, it will calculate all customer IDs and bring the data to calculate table. That's how um, all function works. And then we'll talk about, next one is we'll talk about the AllExcept function. AllExcept is the name itself telling that take the all values except specified values. That's how it works. In the previous video, we talked about all function, where it will ignore the filters that we write in the DAX expression, right? Same way all except works. But excluding the specified value, it will do the calculation of the remaining values. Let's take the example of particular cases. Okay, now we can see here, I'm executing these two statement by using the all except. Okay, the first statement, where we use the geography ID is actually 135. Okay, and the count of rows for the geography 135 is totally 30 customer IDs. But if you look at here, since we use the all except, so it's ignore the whatever the filter criteria that we used it in here, and it brought the count of all customer IDs. Similarly, but when it comes to the second statement, we use the customer ID as our filter. Because of that, what happens? It took the uh, condition. Okay, it's actually uh, since we wrote the customer ID equals to 11602, it's made the part of that results. That's the reason whatever the results that we see here, these two rows are belongs to the 11602. That's how the all except works. It will, when you say customer ID that is mentioned in the all except, it will filter out only that particular data. Okay, that's the reason we see the one row, and here also you can see, but again here it works in little different. Yeah, different in the sense here we just displaying the customer ID 11602. Again, I'll accept keep the one row of 11602. That's how it works there. And even if you execute this particular query, the last query, here again we get the different rows, because based on the statement the behavior is changing. Actually, kindly note that since we use this all except within the calculate function, it behave like a filter. Okay, where it filter out the customer ID data. And but this query, since we didn't use the calculate function and instead of that we use the count of rows, the all except is works in different way, where it ignores the filters, what are the filters that we applied here, and it fetch the data of entire count of customer ID dimension. So that's the all except behavior based on the place, based on the function that used along with all except, the behavior will slightly change. Kindly note that, and you can validate before using the all except function. Okay, because you already noticed here, right, within the calculate it works like a filter, but within the count of rows it works like a excluding the all records. That's the one observation that you need to make. And coming to using the all except in different scenario, not only the filtering the data, you can also, let's say you have the customer dimension, where you have a lot of columns, right? But out of this customer dimension, I want to exclude the um, two columns. One is the geography ID, other one is the address line. Well, I want to exclude those columns from the my results display. Now, using the all except, you can mention the columns which you don't want to display in your result set. So in our query, what I did, since I used the geography ID address line to exclude, so the second results you can see in the bottom where it's excluded the geography ID. Similarly, if we go to right side, the address line one, where is the address line one? Address line one. Yeah, here is the address line one, which is there in the first query. Now if you look at in the second query, you have only the address line two, you don't have address line one. So that those kind of scenarios also you can use the all except, where you can do the minus querying. It's all except is works like a minus querying when you do the displaying the dimension attributes. Because I mean, even you can write this statement instead of all expect except, you can use the select columns and bring which are the columns that you want to display it. But that's not optimal way to write the, when you have a 200 columns or 300 columns in your dimension, right? And out of 300 columns, if you want to exclude only two columns, then it's a very tedious task to use the select columns and write the remaining 298 columns within our DAX query, because it's going to be clumsy. Instead of that, you can use the all except function to exclude the columns that you don't want to display in your results window. That's about all except. The last one we are going to talk about all selected. All selected is works like to select the values that been chosen in the expression. Let's say you have chosen any filters and you want to bring the values of that particular attribute, the dependent attribute or the same attribute, and you can use those values inside of your calculation. All selected function will help you a lot. Let's get into the example. Here, what I did, I just write the variable and the measure. In the variable, what I'm trying to fetch, I'm fetching the sales amount. In the measure, I'm just calculating the internet sales amount based on all selected gender. So here in the select query, the evaluate statement, you can see here I selected the gender equals to M. Now, what should happen? The reference, first, the query execution when it's happened, it should take the reference of this customer equals to gender equals to M, then pass this value to here and calculate the internet sales amount, then display the results. That's how it will work. If you see execute here, so internet sales amount ITST2 is actually where we didn't apply any filter. It's bought entire data because that is a variable, but ITS3 is actually the measure column that we created. And when we pass the gender equals to M, this value is getting passed here. And then the respective sales amount gets stored into this particular measure and displayed in here. right? So that's how the all selected, basically whatever the filters that we select, the same values will directly get passed to the all selected function, and then execute, apply the filter criteria. Even if you look at second statement here, and what I did here, the geography ID I passed 207, but I didn't pass the gender this time. But what will happen, since the DAX will use the lineage method, so because all these columns are coming from the same dimension, right, customer dimension, they will have a column to column, they will have a lineage. So whatever the genders that belongs to the 207, based on the 207, let's say if the geography ID is 207 equals to male, all that gender information will get passed to here and get summed internet sales amount and stored under the total sales 3 value. That's how it will work. So either the all selected will take the values from the filter expression that we write directly, or using the lineage, whatever the lineage that have, it will use that lineage and take the respective values, and then do the calculation based on our whatever the calculation that we asked here, right? Here we asked the sum calculation. Instead of sum, if you put the average, and then it will take the all the gender IDs belongs to 207, based on the genders, it will calculate the average sales amount. That's how the all selected function works. So these are the 8 functions, are pretty important and most used function, at least I used in my project to solve the business cases. But there are other filter functions are there, but using those functions, I feel like a little creating some confusion, but they're also good and we used in different places. But as of now, I used only these 8 functions in my project. But when I come to the usage of the remaining function, when I get the use cases, definitely I will create one more video stating that DAX filter function part 2, and I will share that video with you guys. So that's all for this video, and I will see you in the next video with a different topic. Thank you everyone. And